Surfers' Paradise in Queensland is one of Australia's foremost tourist centres, visited by growing numbers of overseas and other sun lovers. And what's more, the Gold Coast city's boom in high tower buildings, shops, homes and holiday attractions keeps on growing. During vacation times, up to 50,000 vehicles daily use the highway and Surfers' Paradise and conflict with people wanting to cross. Such concentration naturally creates a traffic problem. This led to Main Roads Department engineers turning their attention to the bottleneck to see if a computer could improve the traffic flow. The past and predicted growth of traffic through the heart of Surfers is apparent. Planning began in 1968, when the situation was analysed. After an economic study, it was decided to use an online digital computer. Initially, 17 intersections were to be controlled, with a planned expansion requirement of up to 40. A contract was awarded to Honeywell Computer Control Division Australia to supply a computer manufactured in Great Britain. Detectors were supplied by Eagle Signal Company, who also supplied the traffic signal controllers and the interface equipment, all assembled in Australia. A TV surveillance system from Holland was supplied by Philips Australia. Cable makers supplied the cable, produced by Austral Standard Cables in Victoria. The construction phase began by laying the communications cable. This was pulled into underground ducts. Jointing was carried out by Main Roads Department personnel. Atop Paradise Towers, in the heart of Surfers' Paradise, a television coaxial cable was laid to a remotely operated TV camera. Upon completion of the control centre, the computer was installed in September 1969. Followed by several months of program testing and evaluation. The official switch on by the Minister for Main Roads, Mr. Cam, took place in December 1969. Now let's see how it operates. At the heart of the system is the Honeywell DDP 516 digital computer, which has a storage capacity of 16,000 words, each of 16 bits, and a cycle time of 960 nanoseconds. Its assembly from microcircuits permits high packing density of components. The computer program is prepared on punched paper tape and loaded by a high-speed reader. The program is resident in core at all times, and messages to and from the machine are sent via the teletype. A data acquisition console allows online access to the program. The computer scans input information 40 times a second, performing control calculations once a second for every intersection. Results are compared against a background pattern automatically altered depending on traffic demand, ensuring a continuous flow. But should the computer system fail, lights revert to a fixed cycle. Current intersection and detector data are displayed at the control center. The traffic light sequence is indicated in the square illuminated buttons, and the vehicle detector signals are circular lights. If desired, intersections can be controlled from the mimic panel. A closed-circuit TV system provides a complete view of the controlled area. Vehicle detectors consist of a coil of wire in the pavement, and 66 have been installed to register the presence and passage of vehicles. The loop detector was selected because of its reliability and ease of installation. A traffic control box houses the sensor units. This diagram shows the system concept of signal control and TV surveillance. Coded data is transmitted by cable to the control center and into the main distribution frame. This frame provides circuit test points and drives the mimic panel. Signals are decoded and sent to the computer through the process interface controller, a multiplexer or telephone exchange, scheduling data to and from the computer. Direct access to the system program in the computer is also through the process interface controller. Command signals from the computer return along the same path to the mimic panel and local controller. The traffic lights are switched by the local controller, which responds to the computer commands. Control is completely automatic, except when program modifications or research work are being carried out to upgrade the efficiency of operation. This unique system, the first in Australia, while supervising traffic control at Surfers Paradise at maximum efficiency, is also acquiring important research data for the establishment of further sophisticated traffic control for the 1970s.